notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027. Schedule of videos. These first 3 sections here. All 51 of these videos have been published on YouTube in their entirety. Section 4, measurement. All 17 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 5, statistics. All 18 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 6, algebra. We are now at the 12th video of 22, and hopefully I should finish this section by later in this month, September. After that, of course, we go on to section 7, relations, functions, and graphs by October 2025. Then section 8, geometry and trigonometry by November 2025. And finally, section 9, vectors and matrices, to be completed by December 2025. That's by the end of this year. Please note this disclaimer down here. This schedule is just a projection and is not to be interpreted as a contract with anybody. Section 1, number theory and computation, made up of 33 videos, as I just pointed out, and they are all published on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. These 33 videos you see here on the left, please make sure you view all of them and know them. A reminder here, you need to know the times tables 2 to 12, especially since calculators are not, I repeat, not allowed in paper 1. Section 2, consumer arithmetic. As I just said, all 12 of these videos have been published in their entirety on YouTube. Section 3, sets. All 6 of these videos have been published in their entirety on YouTube. Section 4, measurement. Out of these 17 videos here, 5 have been published in their entirety on YouTube, as indicated by these highlighted in yellow, and the others are only partially published on YouTube. Please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 5, statistics, 18 videos. Out of those 18 videos, these indicated in yellow have been published on YouTube in their entirety, and the others are only partially published on YouTube. Again, please see directions in the description below for full access to these videos that are only partially published on YouTube. Which brings us now to section 6, algebra. This section is made up of 22 videos. Before we go on, recall I said in the introductory video that you will need a good math textbook, or maybe a set of 2, to get especially more practice questions. CSEC recommends the following, shown at right. From these, please pay close attention to these last 2 down here, since they form a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math exam. This is a picture of volume 1. Mathematics, a complete course with CXC questions by Raymond Tulsi. And this is a picture of volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, very recently, late 2024, I think, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only. You can navigate that website by topics or years, where all questions for the past several years have been worked out for you. If you still have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely it will be explained to you. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page for that website looks like. This is the home page. You will have to first register and then sign in. Again, this is the URL. That URL will be in the description of this video below so that you can easily click on it and be redirected to this website. Just a reminder that the formula sheet is provided for CSEC math examination papers. This formula sheet you see here on the left. There will be a link in the description below from where this formula sheet can be downloaded. Of course, if you have the full syllabus, this formula sheet is included in the syllabus. A closer look of that formula sheet. This is the top part of the sheet. Note, you do not need to learn these formulae on this formula sheet, as this sheet will be provided during the examination, as I just said. And this is the below part of that same formula sheet. And while you do not need to memorize these formulae, you do need to know when and how to use them. Overview of section 6 algebra. We already completed objectives 1 to 4 in these 4 videos here. Continuing with overview, we also completed objectives 5 to 7 in these other 3 videos here. Continuing with overview, we also completed objectives 8 to 11 from this page here in these videos here, which means that we are now at objective 12, which is this objective here, which says linear inequality in one unknown, video 12. And after that, we have these 5 more objectives to complete this section of the syllabus, section 6, which deals with algebra. And we will complete those in these last 5 videos. So we have 22 videos from 21 objectives. So as I said, we have finished up to 6, 11, and that was video 11. Out of those, these 4 indicated in yellow have been published in their entirety on YouTube, and these others only partially published. Right now, we are here, 6.12. When this video, video 12, is completed, it will only be partially published. So, objective 12, what does it say? It says, solve a simple linear inequality in one unknown. Well, we will begin with simple, and by the time we get to the end, it may be a little more difficult. But if you understand them, then the simple one will be simple. Now we will use the thermometer scale to explain the idea of inequality. Here is a temperature scale. On the left-hand side, you have degrees Celsius. Now, if the temperature is 20 degrees Celsius, you know exactly where that can be shown on this scale, exactly. So the temperature is equal to 20 degrees Celsius, if you know that. But if you are told that the temperature is greater than 20 degrees Celsius, you don't know exactly where that is. So it can be shown on the scale at the right by an arrow with a hollow dot at its starting end. So we start at 20. We are not including 20. We said it is greater than 20. So it is any temperature up here greater than 20. Now, because this expression does not specify a particular point with an equal to, it is called an inequality. Any answer above 20 degrees Celsius will satisfy the inequality greater than 20 degrees. So this is what we mean by inequality. As I said, the hollow dot means that 20 is not included. Now, sometimes if the temperature is equal to or greater than 20 degrees, written like this, that sign there means equal to or greater than. While you still do not know the exact point where that is, we can show on the scale at right an arrow with a solid dot at its starting point. So it looks like this that you see here, this arrow going up here. But notice the dot is now solid. This solid dot means that 20 is included in the temperature. So if the temperature, theta, is less than 20 degrees Celsius, again, you don't know exactly where that is. So it can be shown on the scale at right by an arrow with a hollow dot at its starting end. The hollow dot means that 20 is not included. Looks like this that you see here. The hollow dot means that 20 is not included, as I said. Now, if the temperature theta is equal to or less than 20 degrees, it is written like this with this sign here, which means less than or equal to. And while you still don't know the exact temperature where it is, it can be shown on the scale at right by an arrow with a solid dot at the starting end. Looks like this. It now includes 20 and everything or anything below 20. So as I said, the solid dot means that 20 is included. If an expression does not have equal in it, as theta is equal to 20 degrees Celsius, but this sign here, which means less than or equal to, greater than or equal to, such an expression is called an inequality. An inequality does not have a specific number as the answer, but rather a range of numbers as the answer. If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. Now, just to be clear, consider this function here, y is equal to 2x plus 3. Now, if we choose values for x, say 5 and 4 and so on, and go down to -5, we can calculate the corresponding values for y. So when x is 5, y is 13, when x is 2, y is 7, and so on. If we plot that on a graph, we get a line like this. For each x value, there is one and only one corresponding value for y. Now that's called an equality. So if you pick 4, for example, there is only one value for 4. And as you could see over here, that one value is 11. So if we go up here with 4 and we come across, we arrive at 11 here. Now, if we change that to y is less than or equal to 2x plus 3, now we can still find y is equal to 2x plus 3 and plot that graph. But this doesn't say equal. It says less than or equal to. So the blue line actually includes the equal, but what about the less than? So if x is less than 4, then y must be less than 11. So remember we said when x is 4, y is 11. But if x is less than 4, let's pick some points in this green area here. Let's pick a point here which is less than 4. You go up and you come across here. Notice this is less than 11 because 11 is up there. Pick another point less than 4. Here. Somewhere between 1 and 2 is less than 4. You come across, this of course is less than 11. Pick another point. Say here, -1, it will be 1 which is less than 11. And you pick another point here, somewhere between -2 and -4. You come across here, notice this here is less than 11 because 11 is up there. And for good measure, let's pick another point less than 4. Now this is close to -4. You come across and your answer is actually -4 down here. It is less than 11. So if you pick any number less than 4, y will always be less than 11. In addition to the original line, the equal part, now any and all values for x indicated by the light green side will satisfy the less than part of the inequality. Y is less than 2x plus 3.